1 to 1.9 and then 2 to 8. Okay, make sure that it's the same distance between all of your ranges. Next part. Box and whisker plots. A lot of people don't understand these, but if you'll watch closely, I'll do everything in my power to make them make sense. A box and whisker plot is a way to display data to see how dispersed it is, how spread out, and where are there more numbers located. It divides the data into quartiles. Look at the word quartiles. What's the root word? Quart. Do you know what quart means? 4. Okay, it's another something that like let's see. Well, like quarts. I mean, why do they call them quarts? Because there's 4 of them in a gallon. 4 quarts to a gallon. So anytime you see that Q-U-A-R-T, think 4. Say quartiles 4 that each contain 25% of the entire data. Probably didn't know that. When you see a box and whisker plot, it does divide it into quartiles. And let me show you what those quartiles are. From here to here, that's one group. From there to there, that's another group. From there to there is another group, and from there to the end. That's 4 different groups. This group, this group, this group, and this group. Each of those groups contain 25% of your numbers. So if you had like a really tiny, like just something like that, 25% of your numbers there, that means a lot of your numbers is between there and there. A fourth of them. Even though it's such a small group, there's several numbers in between them. Okay, back up here. We know that the median of a set of data divides the data into 2 equal groups. So that's the first number that's on your box and whisker. We'll talk more about it in a second. If we then divide the 2 equal groups created by the median, we have found the first quartile and the third quartile. These 3 values, along with the maximum and minimum, make up the 5-point summary of the data that we must use to create the box and whisker plot. Excuse me. The distance between the minimum and the maximum we have learned is the range. Isn't that right? The range is the, let me go back to our number down here. If this was all of our groups of numbers, a picture of our numbers. This is the smallest number, this is the biggest number. The smallest number 30, biggest number is 80. What would be the range there? 50. The biggest number minus the smallest number. That's all they're telling you there. The distance between the first and third quartile is known as the interquartile range. What's the first and third quartile? What does that mean? This is the first quartile. This is the third quartile. The distance in your box there, that's known as the interquartile range. Okay, because again, first quartile, that's just a name for that, and third quartile. So let me summarize that. Watch real close, and this hopefully will make more sense to you. If you have a group of numbers, do you remember how to find the median? It's the middle, right? This is the median. Whatever your median is, that's going to be the middle of your box. This is your biggest number. This is your smallest number in your group. Okay, think about it. When you find the median, you've got this set of numbers. Let's say we've got 11 numbers. What number would be in the middle? The 6th one. If you take that median, does it make sense that since that's the middle number, it divides it into 2 equal groups? You've got 5 below it, 5 above it. Correct? So this group of numbers here is the 5 that would be below it. This group of numbers here would be the 5 that would be above it. And then you've got the median in the middle. The first quartile is the median of your first group of numbers. The third quartile is the median of your top group of numbers. Yeah. So again, there's your 5 different points. Smallest number, biggest number, median, the median of the lower group, the median of the upper group. You put those on a number line. There's your box and whisker plot. Let's work some problems. It says construct a box and whisker plot using the table from example 1. So we're using those same numbers again. Here's the table. So first thing we got to do, again, put them in order. And let's see, instead of putting them in order, let's find the median. How many numbers are there? We've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There's 25 numbers. Will we have a true middle? Yes. So we've taken and we put all of our numbers in order. Here they are. Now we're wanting to make a box and whisker plots, and this is how easy it is. Just watch. Here's the numbers you need. You need first the median. The median, since they're now in order, is simply the middle number. Since there's 25 numbers, the median is going to be the what number, Jose? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 13th number right there. Okay, now let me show you what to do. You need that number. Raise your head up, Joey. You need the smallest number. You need the biggest number. And the other numbers that you need, once you find that median, you see that it divides it into two equal groups. It divides it into this group of numbers, and I wish that other one was moved down, this group of numbers. And you simply find the median of this group of numbers. So the first group of numbers has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers in it, and we've got to find the median of those numbers. There's going to be two numbers in the middle. 1, 2, 3, 4, 5. The 6th and 7th are in the middle, right? And the same way with the other ones. 1, 2, 3, 4, 5. The 6th and 7th will also be in the middle. You add them together and divide by 2, you'll get 2.05 here. And here you'll get, well, it's kind of obvious, 2.8. Add them and divide by 2. You get 4.1. 4.1 divided by 2 will be 2.05. So that's your box and whisker. Let's draw it. Let's see. We've got this is going to be kind of nasty. We've got to do 1.1. Let's do it like this. We got to go all the way up to 4.7. Let's see. Let's think this through. But now I can't really do it, but you can space it out to where this doesn't have to be exact. I can say, okay, this is going to be 1, this is going to be like 1.5, and this is going to be 2. 2.5, 3. 3.5, 4. 4.5, 5. Because if you don't, you're going to have tons of little tick marks. And I mean, again, it's not exact, but as long as you're close, I'm good. Smallest number, you got to put it on there. Where's 1.1? Right next to the 1, right there. Where's 4.7? Let's see, this is 4.5, so it's going to be a little bit closer to 4.5 than 5. There's your smallest and your biggest. The next thing I'm going to do, and I'm doing it in different colors to where you can see, the next thing I'm going to do is the actual median, 2.2, which is, let's see, this is 2.5, 2.0, so about right here. Next thing you're doing is 2.05, which is really close to 2. It's right after 2, nearly right on it. And the last one, 2.8, which is about right there at 3. Put those 5 numbers on your line, and you're nearly done. Now you just got to draw your box and your whiskers. Here's your box. With me? And your whiskers, I wished I'd done that in a different color so you can see it better. There's your box. And we draw a number down through there, and then here are your whiskers. Yep, that's it. To where once you're given a box and whiskers, you know all the information. Think about it like this. We took all these numbers and we represent them with this. Because we know now, because think about the way you divide it. You found the median. Once you find the median, it divides it into 2 equal groups. And then you found the median of those groups. So do you see why you've got 4 divisions, 4 equal divisions, to where here's a fourth of your numbers. And look here, here's a fourth of your numbers. Between there and there is a fourth of your numbers. And can you see that from up here? You got a ton of numbers. From there up to 2.2, 2.3. There's a lot of numbers located right there. Actually, a fourth of them. And then you've got a fourth of your numbers from 2.2 up to 2.8. And then you've got a fourth of your numbers that are located from 2.8 up to 4.7. So that's all a box and whisker plot does, is divides your numbers into 4 equal groups. You can tell, okay, where are most of your numbers located, which in this one, we've got a ton of them located right there. Okay, you can tell what your highest and lowest numbers are, and there's just so much information that you can tell from that box and whisker plot. Here's the lowest, here's the highest, here's the median, And this is the median of the lower group, and this is the median of the higher group. Yes, sir. No, it does not. Because it's going to be on one side or the other based on where most of your numbers are located. Let's see what else we've got. It is. You're exactly right. It's not hard. It's one of those things to where there's not a lot of steps, but it takes a while because of that. We've done that. It says for the data represented. Okay, now we're using this box and whisker plot. And given this, and this one it is right in the middle, and like I said, it doesn't have to be. But given this, let's do it backwards now. Okay, for the data represented in the box and whisker plot below, give the values of the following. The lowest score. What was the lowest score? 30. The highest score? 80. Upper quartile. And when it says upper quartile, a while ago I was calling it the third quartile. That's this one. It's going to be 65. The lower quartile? 45. The median? 55. The interquartile range. Let me explain this again. The interquartile range is simply, I guess you could call this your quartile, I don't know. But the interquartile range is how wide your box is. And is it 40? I'm sorry, 45 and 65, which is 20. Again, range is the biggest minus smallest. You just subtract. Anytime you're looking for a range, you're doing the bigger minus the smaller, which, be careful because there's two different types of range we talk about in math. This type of range, and then on this past test we talked about domain range. Okay, that's two completely different types of range. The last thing I could have asked you on this is what's the range of your entire group of numbers? What would you tell me then? 50, because the smallest is 30, biggest is 80, so the range of the whole set of numbers is 50.